Alright, let's get started with section R4. We're going to be talking about polynomials. So, a couple objectives here today. First one is to recognize monomials. So we're going to start from the very beginning. So, a monomial, single variable. A is your coefficient out in front. K is going to be your degree. Alright, X is the variable. So, if we have 5x squared, 5 would be your coefficient. 2 would be your degree. And this is a monomial because it's a single term. No addition, no subtraction going on here. So we have a couple examples here. 6x squared, coefficient 6, degree is 2. Even if we get into more complicated things like square roots, the thing in front of the x, the negative root 2, is still the coefficient, and the 3 is the degree. Now, couple small things here where we would not have a monomial, non-monomial, is about the exponent right here. If the exponent is not a whole integer, right, if it's fractional, 1/2, or if it's negative, we are not a monomial. Alright, it's got to be a positive integer. Alright, and so if we have a half or a -3, we are not monomials. So, with that in mind, try problem 7. Pause the video, try problem 7. Alright, let's recognize some polynomials now. We'll expand things out a little bit. Alright, so polynomial is just a combination of a bunch of monomials, right? The A out here, the first coefficient here, is the leading coefficient, so we'll use that from time to time. And the degree is the biggest exponent you can find. Now, we want to write these in standard form. I think that talks about that in a few slides here. But standard form is just putting them in order from biggest exponent down to just a constant here at the end. Alright? So, you'll see this one is in standard form, x cubed, and then x squared, and then x to the first, even though you don't see the 1 right here, and then the constant 2. So we have 4 different coefficients, -8, and 4, and -6, and 2. And don't forget that the coefficient of the x term here is -6. Don't forget that the minus comes with it. And the degree, what's the biggest exponent you can find? It's the 3 here, so that's your degree. Alright? So, a couple small things on this one. 3 would have a degree of 0, because it's 3x to the 0. And then 0 here has no degree, because there's nothing going on at all. Alright, so knowing that, see if you can do problem 17. Alright, objective 3. Now we're going to take our polynomials, we're going to add and subtract them. So this is all about like terms. 5x to the 4th and -3x to the 4th will match up. And so if we're going to do the sum here, we're going to combine those together. And I like to do it vertically here. Put them on top of each other. The 3x to the 4th, the plus 4x cubed, the plus, and we need to put a little space in here, 7x squared. It's not going to really line up. And minus 3x plus the 1. So let's go straight down. We've got 2x to the 4th. We've got plus x cubed. We've got the 7x squared all by itself. And then we've got minus x. And then we've got minus 6. Alright? Same thing when you're doing subtraction, but just be careful with that negative here. I'm going to rewrite this so we can have some space. 5x to the 4th minus 3x cubed. And then we're going to have, and you might want to just put a placeholder in here, 0x squared plus 2x minus 7. And then remember when you're doing subtraction, I like to put a big minus out here and circle it to know that we're going to change our sign. So we're going to minus the -3x to the 4th. We're going to add the 4x cubed. And we have 7x squared. We've got -3x, and we've got plus 1. So when we subtract, we're going to change signs. So that means that we'll add here and get 8x to the 4th. We're going to subtract here and get -7x cubed. We're going to subtract here and get -7x squared. We'll add here and get 5x. And we'll subtract here and get -8. So just be very careful with your signs, and you'll be able to do these just fine. Try problem 29. Alright, now we're going to multiply. So the most common thing is multiplying polynomials. This is your box method we talked about in class. You can also do it a number of different ways. I prefer doing it this way, and so this is the one I'm going to show. If you have another method that works for you, go ahead and do what works best for you. 2x squared minus 4x plus 5, and so we've got 6x cubed minus 8x squared, and all I'm doing here is I'm just going to match up straight down and straight across and multiply. So in this one it'd be the 4x times the 3x, and I'd get negative 12x squared, and then I'd get 16x and 15x and negative 20, and the nice thing here is that my like terms are going to be on diagonals from each other. The x is the x squared. So I've got 6x cubed minus 20x squared plus 31x minus 20. All right, your turn, problem 45. All right, so we have some special products here, and we do FOIL. We know that one. So if it's two binomials, right, we can do the foiling, and you guys know how to do that. So a couple examples here, and we'll go x squared, and this is going to be minus 4x plus 4x minus 16. So this is a special formula. It gets us x squared minus 16. Here we've got x squared minus 5x minus 5x plus 25, which is x squared minus 10x plus 25. It's going to be another special formula. On this one, no special formula. We're just going to have to do it. X squared plus 4x minus 3x minus 12. X squared plus x minus 12. And lastly here, don't forget to multiply these coefficients. 15x squared. And then we've got the outside, which is plus 6x. Inside, minus 20x. And last, minus 8. Let's combine those middle like terms. 15x squared minus 14x minus 8. All right, so a couple problems for you to do, 47 and 55. Okay, so here's those special products that we talked about. If it's an x minus a and an x plus a, we lose the middle term. Remember, that was this one right here. The minus 4x and the plus 4x cancel each other, and we can just do the f and the L of foiling. The O and the I, the middle terms, cancel. So we get x squared minus a squared. All right, we also have the special product for when we have x plus a squared. That was this one here, the x minus 5 squared. Notice what happened. The middle term here is twice 5. That's the formula. You multiply the a and the x together, and you double it. Okay, so that's the formula. And then a squared and x squared on the ends. All right, so using our special formulas now, we can go straight to answers on these. This is going to be x squared minus 64. No middle terms, because it's an x minus a and x plus a. Here we're going to say x squared. What's 3 doubled? 6x, and then squared, and get 9. All right, 16x, be careful with this one. It's not doubled of the 1. It's 1 times 4 is 4. Double that. So 8x, and then plus 1. And then lastly, 4x squared. 7 times 2 is 14. Let's double that, and we'll get 28x plus 49. Negative 7 times negative 7 is a positive. Notice how the middle terms match up with the signs inside. All right, so use your special products, 65, 67, 69. Give them a shot. All right, so now what happens if we cube a binomial? So this is foiling and then multiplying again. This is x plus 4, x plus 4, x plus 4. So I'm going to start by just foiling the first two, and we'll get x squared plus 8x plus 16 from our special formulas. And then we can go box method here and get x cubed, 8x squared, 16x, 4x squared, 4 times 8 is 32x, and 16 times 4 is 64. So we'll get x cubed plus 12x squared plus, what do we got here? 48x plus 64. All right, x minus 5 cubed. We're going to do the same thing. I'm going to do the foiling right off the bat. We're going to have x, let's see, x squared minus 10x plus 25. That would be foiling the first two. And then I'd have an x minus 5 to finish. Skip that first step there of this one. Okay, we're going straight to it with our special products. X cubed minus 10x squared, 25x minus 5x squared, and what do we got here? 50x, and then we've got negative 125. And so we've got x cubed minus 15x squared plus 75x minus 125. Okay, follow those steps. 85 is yours to do. We're going to cube a binomial. All right, if only there was a special product for this. Oh, there is. Look at this right here. We've got a special pattern here. So x cubed, 3 times ax squared, 3 times a squared x plus a cubed. You'll notice down here, it's kind of hidden right here, but all right, the first one, 3 times ax squared. The coefficient here is 1. So what's 3 times 5? 15. What's 3 times 5 squared? 5 squared is 25 times 3 is 75. And then 5 cubed, guess what? 125. So we've got our answers right there. Notice the change on the negative. We'll go negative, positive, negative. Get those down in your formulas. We'll do some practice with them. Pretty soon you'll have those memorized, and that's going to be helpful. You'll knock those problems out pretty quickly. All right, 85, try it either using the pattern or by multiplying it all the way out. All right, forming the difference of two cubes. We're going backwards here, so notice we've got this one. Okay, x minus 1, x squared plus x plus 1 will get us x cubed minus 1. So, forming the sum of two cubes, x plus 2, x squared minus 2x plus 4. Here's our special formula. If it's x minus a, ax, a squared. So notice what we've got up here. A is 1. So we've got 1x, and then 1 squared is 1. Okay. Sum, same thing, but we just do a sign change here so that we can cancel some things out in here. A, 2, a, 2. So these ones are going to match. And then if we square the 2 here, we get 4. These ones are very helpful. Have these down in your notes. We're going to use these a lot as well. Okay, difference of two cubes, sum of two cubes. All right, now let's get into dividing polynomials using long division. All right, so just a reminder here how to do long division. I'm not going to do too much of this, but we're going to use it for polynomials. 987 divided by 14. Does 14 go into 9? No, it does not. Does 14 go into 98? Sure, it does. How many times? Maybe 5. 5 times 14 would be 70. So another one would be 84. Let's see. Might be 7. Let's see. 7 times 10 is 70. 7 times 4 is 28. Oh, comes out clean. There we go. All right, so that comes down as a 0. Then we bring down the 7. How many times does 14 go into 7? It doesn't. Okay, so we put a 0 up there. And then we've got another 0 here with a decimal place. We can bring it down. How many times does 14 go into 70? It goes into 70 5 times. 5 times 10 is 50. 5 times 4 is 20. So it comes out exactly. We have no remainder. All right, so it's going to be 70.5. All right, that's the long division for two integers. Not gonna use that too much, too often, okay? But we are going to use it for dividing two polynomials, all right? So we got to be able to do long division of polynomials. Here's how it works. Take your divisor, and we're gonna say 2x cubed minus 3x squared plus 5x plus 2. On the outside, x squared. Now make sure you put a placeholder for every term. There are no x's, but we're going to write that. Plus 0x plus 1. Okay, that's the setup. Here's what we do. We take leading terms and divide it by leading term. What's 2x cubed divided by x squared? The answer is 2x. And I'm going to put it over the x just so we're lined up. Now here's what we're going to do. We're going to multiply that 2x by every term, and we're going to bring it down. So we've got 2x cubed plus 0x squared plus 2x. And we're going to subtract straight down, just like we did with the long division of the normal integers. Okay, those cancel out. We've got negative 3x squared. We've got 3x, remember we're subtracting. And then we're going to bring down the last term, plus 2, just like we would in normal division. Okay, normal long division. Let's start over. We're going to take our leading term, divide it by our leading term. What's 3x squared divided by x squared? Negative 3. And let's start all over again. Negative 3 times everything. So negative 3 times x squared is negative 3x squared. Negative 3 times 0x is 0x. And negative 3 times 1 is negative 3. We're going to subtract straight down. We're going to get 3x. We're going to get plus 5. Careful, careful, careful with your changing signs. And now we're out of things to divide because x is smaller than x squared. X to the first is smaller than x squared. So this is our remainder. We're going to write plus 3x plus 5 over x squared plus 1, the original divisor. Okay? And so this is our answer. Okay? I would imagine we might have some questions on this, but follow those steps. Give this a shot. All right? I want you to try problem 93 in here. Okay? 93. Give that a shot. All right. Working with polynomials and two variables, we'll start to wrap up here. If we have two variables, an x and a y and a 5, okay, two variables, degree is 4. The degree is 4 because the biggest thing I can find is right here, 3 plus 1. We get to add them together. Two variables, x and y, the degree is 3. This one wins right here. 3 is bigger than 2. Two variables, degree is 4 because of this one, this one, this one, this one. They're all 4. All right, so they even out. The degree is, doesn't matter where you pull it from, the degree is 4. All right, so let's use the square of a binomial formula to multiply these two things together, and then you'll try 79. This is a special pattern. Remember that it's square this, 9x squared, square this on the edge, plus 4y squared, and in between we're going to minus. We're going to multiply these two things together. What's 3 times 2? 6. Double that, 12. xy now, though. All right? And that's your special pattern. 79. Use that special pattern, see if you can get it. All right, that's it for R4. If there's any questions, and there may be on this one, this might be the first one where we're kind of stretched a little bit, make sure you're making notes of which ones you want to go over, and we'll talk about it in class. Good luck.